Hello, I'm Akshata Gupta. I will be presenting our work Discriminative Region Based Multi-Label Zero Shot Learning. It's a joint work with Sanat Narayan, Salman Khan, Fahad Khan, Ling Shao, and Mubarak Shah. I'll start by comparing our problem statement with multi-label learning, which is a fully supervised method. The goal of multi-label learning is to learn and predict all the labels in the image. Here the model is trained on a full training set and at test time, when given a sample for which it predicts from the set of labels it was trained on. On the other hand, multi-label zero-shot learning is a different problem from standard supervised multi-label learning. Take a look at our training data again. It doesn't contain visual samples from categories person, nighttime, girl. In this case, the model is learned on full training set and is expected to recognize unseen labels whose corresponding visual samples are never seen at the training time. The goal here is to learn the similarities and dissimilarities between the labels, which is usually done with the help of word-to-vec embeddings. Now I will explain limitations from some existing multi-label zero-shot learning approaches. Most of the people solve multi-class problem where single label per image is given. Some papers use object detectors to identify needed region for recognizing the label. And in some cases, they learn to recognize only dominant labels while ignoring the abstract and small regions. We mainly compare our method with the recent CVPR method, LISA, which learns a shared attention over all the labels. And then the learned attention maps are spatially pooled and multiplied with the label space. We learn the model to get separate category-wise attention maps for all the objects. Then spatial top-K pooling is applied over all the categories. By doing so, we get region-level reasoning along with the utilization of holistic context. Now I'll present a proposed architecture. The images are passed through a backbone feature extractor such as VGG to obtain spatial XR and global XG feature instances, which are then passed through a convolution layer and then to a proposed module BIOM, which learns to aggregate region level and scene specific context to enhance the region features. Then the enriched features EF are mapped to the joint visual semantic space to relate them with the class semantics, which results in the feature M. Notably, our design ensures region-level feature enrichment while preserving the spatial resolution up till class predictions are made, which minimizes inter-class feature entanglement requisite for large-scale multi-label ZSL or GZSL. Now I will explain a proposed module BIOM, which incorporates scene and region contextual blocks which learn to aggregate scene specific and region level context respectively, which is in turn used to enhance the region features. Region contextual block RCB enriches each region feature by attending to all regions with the image and using pairwise relation between them. Scene contextualized block SCB enhances the region-based latent features based on their congruence with the global image feature. Now I will present our results on OpenImages dataset. Our approach outperforms LISA with an absolute gain of 31.9%. Here I present class-specific attention maps for the ground truth unseen classes. Now I will present the evaluation metrics on NUS5 dataset. Here I present some class-specific attention maps for ground truth unseen classes. Along with that, I also present top 5 predictions for each image for ZSL task. We have also compared with the existing MLZSL approach LISA in terms of resource efficiency. As we can see, our approach although takes more flops and almost similar memory, but the training time is reduced for both the datasets. Thank you for coming to our poster session.